Hi everyone, we're going to do Leetcode number 326, power of 3. So in this problem, we're given an integer n and we need to return true if it is a power of 3, otherwise return false. So this integer is a power of 3 if there exists an integer such that n is equal to 3 of x. So if we have an integer n, we need to see if there is a power of 3 number. So basically what we're looking at is something like either 1, 3, 9, 27. So anything that can have can be converted to the number 3 with a power. So can be any number, so any index number. So this is a pretty straightforward problem. This first solution I'm going to show you is what we can do is a loop. So we're just going to take the input n and we're just going to keep dividing it by 3 until we get the number 1. So in any stage where we divide by 3, we're going to check if there is a remainder when we divide by 3. So basically what we can do is we can create a while loop and then we can just check n modulus 3. If it is equal 0, we're just going to keep dividing it by 3. So when we do this, once the loop ends, either we have reached 1, the number 1, or there is a remainder, we're just going to return n equals 1. So when we do this, we know that if it is true, then it's a power of 3 number. One more thing we have to check for is for zeros and non-negative, also negative numbers. So basically, if you have anything that is below 1, you have to automatically return false. So this is the first solution that we can use for this problem. Let's just run this test case and see if we have a test case that passes. And as you can see, we have an accepted test case here. So let's just submit it and see if the submission is accepted. So we have a accepted submission here. So this is a valid solution to this problem. So basically this solution has a runtime of log 3n. So the reason why it's log 3n is because every time this loop goes through, it divides by 3, divides the input by 3, and that's why it's log 3n. And we have a space complexity of O of 1 because we're not taking any additional memory. So that is the first solution. We can also do another solution for this. And what we can do is something called base conversion. So if we have our normal decimal numbers, the digits from 0 to 9, these numbers have a base of 10. And if you look at any power of 10 numbers, so basically 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, you have these numbers, and what is in common is that it starts with 1 and 0, 1 and 0, 1 and 0, no matter what. And something about numbers in bases. So for example, you have binary numbers, which is a base of 2. If you have the same number in binary, this will actually be 2, 2, 4, and 8. So these are power of 2 numbers, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So you see that there is a similarity in the numbers. There's a pattern here. It starts with 1 and 0, and if you convert it to base 3, so if each digit has a base of 3, this becomes 3, 9, 27. Same thing, we start with 1s and 0s. So basically what we can do is when we take the input number here, we can convert it into a base 3 number and check if it starts with a 1 and 0. So this is going to be really simple. We just type here return, and we're just going to take the n number, the input, and change it into a string, and then we put an input of 3. This will make it into a string, and it will convert the number to a base of 3. And then after that, what you need to do is you need to look for the 1 and 0 at the beginning. So you can just use the match method, and we can use this following regular expression. So there's a caret, so it starts with 1 and 0, and we don't really care about what goes after that, so we can just use the star key and then just the $sign to put the end anchor. So this will actually match whatever. If there is a 1 and 0, it will actually return the result. So we need to return a boolean. So what we can do is we can just put 2 exclamation marks, and if there is a match, it will return true, and if there's no match, it will return null, and it will convert it into false. So let's just run this and see if this works. As you can see here, we have an accepted solution as well. Let's see if it passes the submission, and this also passes the submission. So this is the second solution. So for this particular solution, we have a runtime of log3 of n as well, because the reason is when we convert this n number into a string, we're actually converting it into a string that is the size of log3 of n. So when we're doing that, when we do the match method here, we're actually going through each letter in the string. So that's why it has a runtime of log3 of n. And because we're converting this into a string of log3 of n, we're also having a space complexity of log3 of n. So it does take a little bit more memory, or it's more complex in the space analysis, log3 of n, than the first solution. So this is another way of doing this problem. So we're going to take a look at another solution. This is the last solution, and basically what we're going to do is we're going to use a little bit of mathematics. So basically, if you have any index, for example 3 to the power of 4, and then you divide it by, let's say, 3 to the power of 2, this will actually give you 3 to the power of 2. 3 to the power of 2. So actually what I'm trying to demonstrate here is, as long as this number, the numerator, has a larger index than the denominator, then we will be able to divide it without any remainders. So we can use that to actually do some manipulation mathematically to find out the result, whether the input is actually a power of 3 number. So basically we need to find the largest number that is a power of 3. So how do we do that? So the first thing we need to do is we need to find what is the largest number that is possible. So we're using JavaScript here. So the okay, I'm gonna open up the console here on the web browser. So I'm just gonna show you what the largest number is. So you just can use the number object, and then you can look at the property called max safe integer. So you see that long number, that is the largest safe integer. So the next thing we want to do is we want to get the log of this number, or log of base 3 of this number, and we can get the index, the largest index of the number. So let's just do that. So in JavaScript, we don't have a log base 3, we have a log. So that is, I think, log e. So let's just put number dot max save integer, and in order to get log base 3, we just do a division by math.log 3. So that will give us the log base 3 of max save integer, and you get that number 33 and some change. So last thing we have to do is basically we just take 3 and then to the power of 33. So we're just going to look at the floor of that number. We're going to round down that number, and we have that number starts with 5. It's also a large number. So this is the largest power of 3 number, And what we need to do is let's just copy that, and I can close this, and we can just return this number, and we can say modulus n, and it has to have no remainder, so 0 as a remainder. So if this is true, then we know power of 3 is true. And the last thing we also have to check is that if n is greater than 0, because as you know, if n is 0 and it is a negative number, then it's not, it's a, you should have a false value, false result. So let's just test this and see if this works. So as you can see here, we have a pass test case. Let's submit it. And we have an accepted solution. So this is the last solution that we're going to show you. And basically this has a runtime complexity of O of 1. Because no matter how large this number is, it's going to just do this operation. So it's going to be a constant time complexity. And there is a space complexity of O of 1 as well. Because we're just going to have this number, and we're going to just modulus n this, and it doesn't use any additional memory. So that comes to the end of our video. I hope you enjoyed this video, and if you did, please hit the like button and subscribe to the channel. And we're going to do more Leetcodes in the future, and I hope you look out for that, and I will see you in the next video.